a bay, a canal is a cataract, a cave is a cliffs are steep, the coast is a continent, a delta is a desert is an area, a glacier, a harbor, okay, an isthmus, a main, plains, a plateau, an island, a volcano, all right, a sound is a, okay, we're now coming to our next portion of the video, which is climate and climate types. Go ahead and start a new note, and the topic is climate and climate types. That's the topic, and we will identify different climate, and we will identify different climate types. Good evening, class. So this right now, it's going to be a very long PowerPoint presentation. This is going to be on climate, biomes, physical geography of North America. I will upload this to my YouTube channel as well to Google Classroom, and I'll send a reminder out to let you know that it's on Google Classroom. So first thing you want to do when we talk about climate is that there are 8 factors that affect climate, and we use the acronym LACEMOPS in order for us to help us to remember and also to explain climate. So make sure you set up your Cornell notes. So by setting up your Cornell notes, make sure that at the end of your Cornell notes you have a good summary, 3 to 4 sentences, and make sure you have a level 1, level 2, level 3 question. Now, with this larger PowerPoint, you're going to probably have to have more than just 1, 2, and 3 level 1 questions. You should probably at least have at least one for each section. One for each section. So for LACEMOPS, at least one level 1, 2, and 3 question. For biomes, at least one level 1, 2, and 3 question. For the physical geography of North America, level 1, 2, and 3 question. And for climate types, one level 1, 2, and 3 question. So for probably about a total about 12 questions you need to have. Okay, so normally when I teach lace mops, I normally teach this as a foldable, but since we are AP students, we want to go ahead and not do the foldable today and just take good Cornell notes. Okay, so terms that you need to know, you need to go ahead and know that rotation equals 1 day, meaning it takes Earth 24 hours to make one complete rotation on its axis. And a revolution is 1 year, takes the Earth 365 and a quarter days, 1 year to make one complete revolution around the sun. This is one reason why every 4th year we have what we call a leap year to make up for that extra quarter day. Weather, the daily condition of the atmosphere, so that means today is sunny, tomorrow might be rainy, the next day is going to be sunny again. Climate is the weather conditions over time. So basically what that means is, as say take a course of a year, 2 years, 5 years, you notice that it rains, more likely it's going to rain in the wintertime than in the summertime, and that it's very hot or humid in the summertime, and it's maybe not as cold in the wintertime. That is what climate is. And then precipitation is moisture that falls from the sky, rain, snow, sleet, and hail. So you should know, if you remember about the water cycle from 8th grade, that causes precipitation. I think you should be okay when we talk about storms and rain later on in our presentation here. Okay, so what we want to do when we study climate, we want to be able to go ahead and read a climograph. And this basically gives us an idea of looking about temperature and precipitation over time. And if you notice that at the bottom of the climograph of the months of the year, the blue bar graphs represent the precipitation, and then the line graph is the average temperature for each month. So we know that here in Bangalore, India, that the hottest month, looks like it's going to be May, with an average temperature about 30 degrees Celsius. But we notice that in June and July, we know that it has the most precipitation, with about 1,000 millimeters of rainfall. Okay, the L in lace mops is latitude, and latitude is the most important factors in determining climate. And that is basically how far north or south from the equator you are. And the reason that latitude is very important has to do with how the sun's rays and heat strike the earth. Okay, so what I mean by this is that you have what we call insolation, or incoming solar radiation. If you notice on this slide here, you notice that as you're nearer to the equator, the sun's rays hit nearly straight on, and this is one reason why at the equator it tends to be the hottest, is because the sun's rays are hitting straight on, and it's creating more heat. And as you notice, that you're going further north and south from the equator, because the Earth is a sphere, that you get they hit the Earth at an angle, therefore it's cooler north or south at the equator because of the angle of the Earth. Okay, now you have to understand something, that the Earth is tilted 23.5 degrees on its axis. All right. Okay, so we talk about the zones of latitude here, and if you notice that we have uh, three zones of latitude. We have the low latitudes, middle latitudes, and the high latitudes. Okay, the low latitudes is at the equator, and it's within the tropics, and this is where you have it's very hot, very rainy, or very dry, and you only have two seasons: the rainy season or the dry season. Then in the middle latitudes, this is where we have our temperate climates, and this is where you get the actually true seasons, okay? A true fall, a true summer, a true spring, and a true winter. And at the high latitudes, um, we have the polar climates, and there's only really one season. It's just cold. Uh, and very, very short summer of at all. All right. Okay, so if you look at these two climate graphs right here, you can try to pick out which one that is a tropical climate. All right. So you remember tropical climates are at the low latitudes. So there's only two types of seasons, a rainy and a dry one. So write down your notes what you think it is. Is it climate A or climate B? Okay, so we're talking about air masses here. In the northern hemisphere, you have the cold air from the polar regions, comes from the north, and hot air from the tropics comes from the south. And in the southern hemisphere, it's the reverse. And when we're dealing with climate, something that's very, very simple that you need to remember, and that is that uh, cold air wants to be warm, warm air wants to be cold. And the same thing when we talk about air currents or ocean currents as well. Okay, continentality, the effective location on a continent. Okay, one of the besides latitude being one of the most important factors that determine climate, the other one is continentality. Okay, so what you have to look at is that the further inland you go from the coast, the greater the difference in your climate between uh, winter and summer. Okay, so what happens is this. Remember, close to a large body of water equals smaller difference in temperature. Farther away from water, greater difference in temperature. Okay? Water does not heat or cool down quickly. Right? I mean, you probably can see this if you're going to boil water. It takes a long time for it to heat up. And then if you run a hot bath, it takes a long time for the water to cool off. But land isn't. Land releases heat very, very quickly because it's the vegetation. Okay, the vegetation tends to release a heat faster than water does. So the E stands for elevation. Okay, the higher you go, the colder it gets. As you go up in elevation, the air gets thinner and does not trap heat. So the question here is, are there glaciers on the equator, which is just basically ice, right? Ice and snow. If you noticed that picture right there, you notice in the foreground, there looks like is a giraffe. And in the back there is Mount Kilimanjaro, the largest mountain in Africa. Okay. So what happens is this: for about every 1,000 feet in elevation you go, uh, the temperature drops about 3.5 degrees. So, out there on the tropical savanna, it could be 100 degrees out, but as you go up about 14,000 feet, it's probably closer to like maybe 50 or 60 or 40 degrees, 30 degrees as the farther you go up. So this one we talk about elevation. It's something called altitudinal zonation. So the farther up you go in altitude, or farther you go up in elevation, uh, it will affect the different types of biomes and different types of vegetation that will grow. Okay, right here, this is some names for South American climates, okay, or Central American climates. Is the Tierra Caliente, okay, the hot zone, hot tropical coastal, tropical rainforest. The tropical agriculture is grown there, bananas and sugar. Then when you go about up to about from 2,500 feet to 6,000 feet, you're in the Tierra Templada, the most populated zone common in Central America. This is where you build. This is where your coffee, corn, and wheat are grown. And then when you go in the Tierra Fria, from 6,000 to 12,000 feet, uh, you have barley, potatoes. This is highest zone in Central America. Um, you have up to the tree line. Now, you have to understand about the tree line. The tree line is the highest elevation that a tree can grow. And that means because anything up higher than that, the trees cannot grow, probably because it's just too barren. Uh, Maybe you have poor soil and the nutrients, and trees cannot thrive pretty much above the tree line, which is around 12,000 feet. Okay, and then you have the Tierra Helada, which is very cold, barren, sheep grazing, and is right below the snow line. And the snow line is in the Tierra Nevada, is where snow begins on a mountain. Okay, so mountain barriers. That is for mountain barrier. Okay, also known as the orographic effect or the rain shadow effect. All right, this is a very major influence on climate. So once you look at the latitude of some place, then you look at the elevation or the continentality, and you gotta look at the mountain barriers. Okay, so what happens is this: is that the winds blow across the ocean, push moisture inland. Moisture cloud reaches the mountain, it gets popped by the mountaintop and rains on the coastal side. You look at that graphic right there. By the time it comes right out the other side of the mountain, the air is dry. So, which is what we call the leeward side. The leeward side is where the rain shadow is, and on the leeward side of a mountain is that this is where you might find deserts or semi arid regions, or maybe some chaparral. The windward side is where it's very very wet, and it tends to rain a lot. O is for ocean currents. So even the United Kingdom and most of Europe are on the same line of latitude as Canada, they don't necessarily experience the same climate. If you notice here in this graphic right here, the Gulf Stream, which later on turns into the Mid-Atlantic Drift, is a warm current, and what it does is that flows up from the equator and that keeps Europe warmer than it should be at that latitude. Okay, because again, what the ocean current does, because it takes a long time for the uh, water to cool, it has a moderating effect on climate, which is one reason why, for instance, London, England tends to have a lot of fog because you're getting all that moist air in the atmosphere, which causes the fog. Okay, using both methods, how do you explain the existence of a desert region of southwestern Africa? Well, you notice that uh, you have the warm ocean currents in red, then you have the blue ocean currents, which are colder ocean currents, are in blue. You see they're coming off the southwestern uh, coast of Africa right there. Now, remember what I said before that, uh, you know, warm air wants to be warm and warm air wants to be cold and cold air wants to be warm. Well, that's the same thing with ocean currents. Warm water wants to be cold and cold water wants to be warm. And based on the rotation of the Earth on its axis, that creates a Coriolis effect for uh, air currents. The ocean, it also affects ocean currents to a small degree as well. And so what happens is, one of the reasons why there is a Sahara Desert, which is the largest hot desert in the world, is that um, two major factors. One is that as you have the North Atlantic drift starts making its way back uh, southward towards Africa, it gets colder, and once it makes it to the coast of Africa and it starts making its way back to the Gulf and into the Gulf Stream, where it gets warmer, you have that cold water there, which creates uh, drier conditions. Now, another issue there too is that along the uh, the let's say northwestern coast of Africa, right around the Sahara Desert, is the Atlas Mountains that also acts as a mountain barrier, which creates a rain shadow that also contributes to the Sahara Desert. Right. P is for pressure, so you have pressure systems. Now, heavy pressure, heavy cool air brings clear skies and no rain. Low pressure brings light, warm air and usually brings precipitation with it. Okay. At the equator and at both lines at 60 degrees latitude, the air is rising. So where air rises, will get rain. So those areas tend to be very humid. And we see this as well here in southeast Texas. We are in a humid subtropical climate region. And so the humidity means that we have a lot of moisture in the air. And we know that we do rain a lot. And that thing between the high pressure and low pressure system, that's what happened with Hurricane Harvey. Hurricane Harvey was a low pressure system that one reason why it stayed so long along our Gulf Coast was because it was a low pressure that was sandwiched between two high pressure systems. So it had nowhere to go and it had to basically rain itself out. The Coriolis effect. This is something that is very important. You definitely need to know this. This is the reason why uh, winds do not always blow straight. Okay, um, because of the Earth's rotation, they are turned at an angle. In the northern hemisphere, they turn to the right, and the southern hemisphere to the left. This bending of the wind is called the Coriolis effect, and it does have a is important in climate because if you notice, um, like for instance, how our hurricanes form and move is based on the Coriolis effect. So if you notice here in this slide, you can see that they're asking for the difference between the world's major desert. Okay, um, high pressure versus low pressure. Well, again, you look at the Sahara Desert in North Africa. You have the cold air current, which tends to bring it tends to make the climate there drier, so less rain. The Atlas Mountains along that area that helps create the rain shadow. Then we have the along the area right here. You have uh, the dry air sinking from the westerlies turning into the trade winds. All right, so that area along the North Africa right here, where the Sahara Desert, that has this triple whammy, if you will, which is one reason why it creates this very large desert. Okay, so right here we have the uh, acronym LACE right here, and it was developed by Dr. James Peterson at Texas State University, San Marcos in 1990. So if you understand, remember the acronym LACE understand what everyone stands for, and also understand that it's about making connections. Okay, that all builds together, and this is one reason why we can understand our climate. Okay, latitude, incoming solar radiation. How do the rays of the at what angles do the sun's rays hit the Earth? Along with um, you know air pressure system with pressure systems and air currents and continentality and uh, air masses and elevation and pressure systems and storms, ocean currents, they all mountain barriers, they all play an important role in climate. If you understand this, you can understand where the connections are uh, through lace maps. Understanding climate will not be a problem for you. Okay. The tropical savanna. If, now, arid. Okay. Okay.